Okay, well, it's my pleasure to introduce Dr. Derek Morgan. It's pretty easy for me to introduce him. Derek is a member of our team. He's a senior research scientist at NEMAC. He joined us in 2011 and has been working on a variety of these type of tools for forest health over that time. Derek also teaches GIS courses, GIS customization, computer cartography. He also teaches a decision class at UNC Asheville for the Climate Society program. He greatly enjoys teaching and researching and has 13 years of professional experience in GIS. Prior to joining us, Derek got a BA in economics with a minor in applied computer science, a master's in information science, and a PhD in geography from Florida State University. So, welcome, Derek.
Thank you, Jim. Appreciate it. And I'm honored to be here. As you can tell from my background, I'm not a forest scientist. I should also mention I'm not a remote sensing professional. I'm more of a GIS programmer, particularly a web-based GIS programmer. Also, I'm not a comedian, but I would like to ask you, what is a tree's least favorite month? September. So this is a presentation, I'm not a comedian, but it's a presentation about a project that I've been working on, and the whole NEMAC team. Here are the names of all of the team members, and a couple of them are in this room. Diane McQueen is here, David Jones was going to be here, but he's with us next up. And Jim Fox is here. The folks from the NEMAC team have all been a part of this project and really deserve credit for as far as we've gotten with it. So what it is a web application and subscription service that is titled Landsat Forest Area Change Tool, or LandsatFACT. And this presentation discusses the scope of that project and how it's developed. So there are three primary deliverables in this project for us. That is one is a forest change viewer, which you'll see is very similar to FCAD, and would be based on the same code base in many ways. And a subscription service, which I'll talk about, and also a custom request service. So this is a little bit of the presentation overview. I'll talk about the background of Landsat briefly, and then go into LandsatFACT, and then describe those three products that we're developing, and then use a brief case study. So the three primary satellite systems that are being, where the data is going to be pulled from to pull into this project are from the Landsat series of satellites, Landsat 5, 7, and 8. But here you also see a timeline of Landsat and its impressive history, a 40-year history of recording the Earth's surface and different satellites as they've come online and gone offline. You don't hear much about Landsat 6. It actually crashed shortly after launch. It's on there.
So how does this all work? One thing that folks get mixed up on are passive and active sensors. Passive sensor reads, what it gets at the sensor itself, which is what most satellite technologies utilize. An active sensor would be, an example of that would be LiDAR, where things are shot from the sensor to the object they wish to record information on, and then they read what is sent back in return. So in the modern sense for satellite.
Because of that, well actually I'll get to that. But this comes into what could be classified as the bands. And so here I show the bands for the Landsat 8 product, which is the newest product that was launched in 2013, so the data set for that is relatively new. And then the 5, 4, 5, and 7 are down here. And as you can see, there are some band differences between the two groups of satellites. But from these bands, you can actually get an idea of how the vegetative indexes are created. And so Dr. Hargrove talked about NDVI, and that's a measure of greenness. And so that uses near infrared and the mid infrared. Right, okay, sorry. And then there's also NDMI, which is a more of the moisture side of measurement, and that also uses a combination of the bands. And then also, and so that will also be used in the LandsatFACT project. And so NDMI is band 4, or band 4-3 divided by band 4 plus 3. And then also there will be a third index, which is just simply band 7 differencing, which is a shortwave infrared. So those will be the 3 vegetative indexes in this product. And as I mentioned before, the thing that is collected at the sensor is the radiance, and so that needs to actually be converted to reflectance at the surface. So there's a process of doing that, and we'll go through, and we've been primarily Brian and David have been communicating with folks at USGS and Forest Service and Bill Christie and folks to make sure they're doing this in the best practice way, so to speak. So for now, this project is being funded by the Forest Service, but it's for the southern region of states, and this shows the states that will be involved in the initial release of this project. And it shows the WRS2 path row areas across those states. As you can see, there's a 16-day return per platform as compared to the Landsat 7 and 8, offset by 8 days. And this is sort of an example of those 3 different methods, change analysis methods. And you get a taste of the technologies that we're using to build this. It's all going to be hosted on Linux servers in the Amazon cloud. And it's going to be primarily open source tools. So there's a smattering of open source technologies that we're going to utilize. I find this very useful, and this comes from meetings that we've had with David and Brian, talking about the flow of the use of this product. And this is a use case diagram that kind of gets at that. And so Drupal is going to be the content management system in which we manage the subscriptions to the products. And that's something that EMAC has worked quite a bit with. And so basically, users will create an account and then sign up for areas of interest. Interested in the Raleigh region or some area in the southeast. And then they will have the ability to receive emails when there's a new change product available for their area. Or they can make a custom request and say, I just want to know right now in this area between these 2 dates, what are the change products available? Could you send those emails? And those are like the 2 primary ways in which they'll query the system. In the back end on the servers, there will be a PostgreSQL database with PostGIS, the spatial extension enabled, and a series of Python scripts that Brian McLean and David have spent quite a bit of time writing. They've actually even written a ArcGIS desktop plugin that does very similar functions that will end up being on the server. But the one on the server will be open source, as I mentioned, you can read out instead of archive. Another important piece of the puzzle is getting our data. So this little piece, it all hinges on that, in this machine-to-machine connection to USGS servers. And so they have an API in which you can programmatically query the metadata of Landsat images and then also retrieve that. And so that is actually, it's called the Simple Object Access Protocol API, and it's provided at that address. You do have to have an account that has access, obviously, to that. So it's not freely, it's freely available, but it's not publicly, open to everyone. But I believe you can get an account pretty easily. I think you have to make a justification for why you need it. And David Jones filled out the top of it. So this is just an example of getting data to download using this API. So this is PHP that will be running in conjunction with the Drupal concept. This is a more higher level architectural overview of the software environment. And so as I mentioned, Drupal has its own database. It's a MySQL database. But either interfaces through Drupal, and then in the back end we have the PostgreSQL and the viewer and the geoprocessing. And then when necessary, draw the arrows to get information. Then another architectural diagram. This is just us organizing what's going on what server in the file section. So it's not all on the same server, but it's actually a database server. And this is the actual ERD entity relationship diagram of our design for the PostgreSQL side, which is where we will be storing the product metadata for the actual products that we're generating on an ongoing basis or per custom request. And so there's Landsat metadata, which will be pulled through the USGS, and then there's actually Landsat process data, which is the data that we process from Landsat. There's the user area of interest where people said they're interested. And then another one of this, there's the quads. So I'll look at this diagram. So this is a geoprocessing workflow on the server. So we get a new scene, we extract it, we run fmask, which would be used to detect cloud coverage, essentially. We make the quads, which is where we'll be splitting the scene into 4 quads, and compute the cloud cover percent. If the cloud cover percent meets the threshold of which we set, then we would keep the data. Otherwise, we would go back and look for the next viewer scene. So we go back and find the next viewer scene. And then there's a resampling down to 8-bit for Landsat 8 products, because they're at 16-bit. These are already at 8-bit. And then the last step is to make the NDVI and NDMI the base set of methods of product. And this is an example of Python type commands that we use to do that. We use the Numpy library, which is managing large arrays in Python. And stitch it all together in a mosaic. This is actually particular to the thing we're showing the web. So the landing page for users, I'm going to go through with a brief case study here. The Paynes Bay fire that occurred in 2011. Burning about 45,000 acres in Garrett County. So I'll show you kind of the workflow of a user who would have requested that specific data, which occurred in the past, or if there was somebody who signed up. So hypothetically, of course. But there's the create manage account. When you go to this site, you have to create an account, and then if you create an account, an email sent. They'll validate that. So for a custom request, like if we were going back to get this actual data for the fire, they would provide the dates. So it started in May of 2011, so we're just going from April. That should be June, sorry. That should be June. Anyways, you choose the date range and then you choose your area of interest. And we're also going to be providing the ability to upload a shapefile and intersect with it. But this is just showing the open layers polygon select. Or someone could have actually already been signed up for their account or that area, and then they would have actually gotten an email when there was new shape files available. So this gives you an idea of how large an actual Landsat scene is, and then the quad section of that. So you can see it covers most of the counties in the coastal Carolina there. So the ability to break that up into quads definitely is more available. The actual resolution of this data, Landsat data, is 30-meter resolution. And this just shows the naming standard for the standard Landsat data. This is actually so if you remember, there's also the force change viewer, which, as I mentioned, very greatly influenced by FCAT. And that will be always available to the public in general. And so this has no awareness of who's logged in. That would just be serving a mosaic view of all of the products that have been created, the latest products. There's some discussion of putting archive, a certain level of archive in there, but I don't think we've settled on that yet. And so we've done some bit of researching into the best method of serving that data in the web viewer, because one, it's 30-meter resolution. That's really pretty high resolution for this large of an area. So we've looked at tile indexing as a method which uses a shapefile to index to a directory of tapes, which that's the format in which Landsat would come to. We've also looked at virtual raster tables, which uses an XML file to do the same type of indexing to, again, directly geotapes. And we've also looked at single raster mosaic, which is basically stitching all of those geotapes together into a single file. And for each of those, overlap is handled in a slightly different way. And we've also looked at finding the use of a single mosaic with some type of tile or DRT index, where whenever you zoom in to a certain level, it will switch from one to the other. And that server is the GIS web server that has this ability to do that through what's called scaling. So we've been basically looking at how best to do this, and we also, we found obviously reducing down from 16 to 8 gigabit greatly improves performance. And we also found utilizing what's called mosaic overviews, which can be done with GL, ADDO, to specify all of the levels. It increases the size of the actual mosaic file itself, because it builds a node views into the file, but it greatly increases performance in the web view. And this is just an example of some of the testing that Matt Hutchins put together with our intern for the flood. And essentially what it shows is we find that a single raster mosaic with overviews that again is well specified performs the best for us in a way. Better. This is the timeline, and so as you can see, it's very much a work in progress. We're about right here. So we're looking to have you done with this in the next year, and there's going to be a process, obviously, an iterative process of releasing this, and David's going to be sending it out to select users and other groups, state foresters, and potentially other groups to look at it early initially, release out it, get feedback, and revisit the design if necessary. It's also very important to mention all the agencies involved in the funding, as I mentioned, the USDA Forest Service, but also these state agencies and these other groups like foresters. And also important is to consider other Landsat projects that are out there. And I mentioned FMAS, but there are these other projects that are just work on. And I'll give you one last tree question. How do trees get on the internet and log in?